Alright, you're welcome to my YouTube channel once again. Remember, I'm still the volume point. So please, if you've not subscribed to my channel, subscribe, hit the notification bell. Remember, the name of the YouTube is The Sky Academy. The Sky Academy. Tell your friends, tell your neighbor, tell your brothers, sisters. Inform them about this. So today we are going to be starting another concept of motion. So we've looked at linear motion. If you have not watched my video on linear motion, go and watch it. We've looked at circular motion. If you've not watched, go and watch it. We've looked at projectile motion. Go and watch it. So today we'll be entering another topic, which is simple harmonic motion, which is his S.H.M. That's what they call it, S.H.M. Simple harmonic motion. So let's start with question number one. Question number one. They said an object moves with simple harmonic motion has an amplitude of 0.02 meter and a frequency of 20 Hz. Its period of oscillation is dash. Option A, 0.05 seconds. Option B, 1000 seconds. Option C, 0.04 seconds. Option D, 0.4 seconds. How do you solve this? Please remember, write solution and sign it to tell them that you know what you're doing. So the first thing to do is to bring out your data. Remember, I told you that your data has a way of giving you a lot of information about the formula you apply to solve particular question on physics. So an object moving with a simple harmonic motion has an amplitude of 0. So they give us amplitude. What is the amplitude here? 0.02 meter. And a frequency of 20 Hz. So they give us frequency 20 Hz. They give us a frequency of 20 Hz. Okay. Each period of oscillation, that means we're looking for period, which is T, is unknown. So they gave us amplitude, frequency, and sometimes here this will even give you things that you will not use. Because if you watch this, you can use direct formula to solve this. There's a relationship between period and frequency, and that relationship is called an inverse relationship. It means that according to inverse relationship, period is 1 over F. It's an inverse. And frequency is also 1 over T. So both of them have an inverse relationship. So if they gave us frequency and we should look for period, that means I can use this formula. If I use this formula, you have that T is equals to 1 over. So what is the frequency that was given to us? 20. 20, which is 1 over 20. And what is 1 over 20? I have it as 0.05. What is the unit of period? Seconds. So do we have 0.05 seconds in the options? Yes, which is option A. Option A. So now we've been able to solve question number one. Let's go to question number two. Question number two, without wasting much time. Question number two, you know, some of these questions, what do? You get angry and leave the hole for them. A mass vibrates through an amplitude of 2.0 meter in simple harmonic motion with a period 1.0 seconds. Find distance moved from the center of oscillation in 0.5 seconds. So remember what I told you, you bring out your data. That is the first thing. So a mass vibrates through an amplitude of, so they gave us amplitude again. What is the amplitude? 2.0 meter. In a simple harmonic motion with a period, so they gave us period. What is the period? 1.0 seconds. Find the distance moved from the center of oscillation. That means we are looking for the horizontal component, which is called X. distance, which is the horizontal component, and they gave us time E. So the time here is 0.5 seconds. So what formula are we going to apply? You remember they gave us A, they gave us T, and we're looking for horizontal component, which is the distance moved from the center of oscillation, right? So the horizontal component, which is S, is equals to A cos omega t. A cos omega t. Did they give us amplitude? A. They gave us A. Then omega, they didn't give us omega, but they gave us time. So you should recall that omega is equals to 2 pi over t. 2 pi over t. That means any place I see omega, I will put it as 2 pi over t. That means the horizontal component will now be A cos 2 pi over t times t. So I will now have x is equals to, what is my A? 2.0 times cos, so what am I going to have here? 2 times, what is pi? 32/7 or 3.142 times, did they give us time? Yes, the time is 0.5 seconds. 0.5 seconds all over t. What is the t? 1.0. So 20 cos 2 times 3.142 times 0.5. I think I'm going to have it as 2 times this is 1.99. Everything, yes, 1.99. So approximately I will have this as 2.0 meter. So do we have 2.0 meter in the option? Option A is 4.0. Option B is 4. Option A is 4.0 cm. Option B 4.0 meter. Option C 2.0 cm, and option D 2 meter. So with all this, you discover that I have 4 in cm and 4 in meter. So the question is, what is the SI unit of distance? It is a meter, so it can be 2 cm but 2 meters. So the correct answer is option what? D. So question number 3. Question number 3. They said in simple harmonic motion with amplitude A and a period t, the maximum velocity is dash. Wow. The maximum velocity is dash. Maximum velocity. Alright, remember the formula for maximum velocity? You know that can you still recall? Let's say recall that V is equals to omega. Can you still remember this formula? Square root of A square minus S square. So at maximum velocity, remember that x will be equal to 0 at maximum velocity. So if x is equal to 0, that means I have that V is equals to omega then square root of A squared. So this square we cancel this square root. You have that maximum velocity is equals to omega what? A. Now recall that omega is 2 pi over t or 2 pi f. Anyone. That means any place I see omega, I'll put it as 2 pi f. That means maximum velocity will now be equals to 2 pi over t times what? A. Do we have anything like that in the option? We have option A, TA. It can be TA. Option B, A over no. Option C, 2 pi over AT. No. Option D, 2 pi A over T. 2 pi over T. So the correct answer is option what? D. So alright, question number 4. They said for a simple pendulum, the time period is given as 2 pi. So T is equals to 2 pi square root of L over G. If the length L is quadrupled, the new period is dash. What does it mean? How do you solve it? Now, what did they mention? They mentioned period, they mentioned length. That means the relationship between length and period and length is that period is equal to square root of L. You get period is equal to square root of L. Then they now say if, and let me call this one T1. They say if length, which is L2, is quadrupled, that means 4L, right? What will be the new period, which is T2? So remember that T2 will now be equal to square root of 4L. So T2 is the new period. So what do you do? What is the square root of 4? 2. You have it that T2 will now be 2 square root of L. Remember, square root of L. What is square root of L? T. T1, which is also T. I will have it that T2 is equals to 2 times the original period, which is 2 times T. And what is 2 times T? T2 is equals to 2T. Do you have anything like 2T in the option? Yes, option A. That is the correct answer. So by God's grace, we've come to the end of this simple harmonic motion. See you guys in gravitational force. Okay.